All right, so I'm back to do 3 examples with you. So when we're looking at our end behavior, we're asking the question, is it top heavy, is it bottom heavy, is it balanced? And based on that, we have some different strategies, okay? So first one, is it top heavy, bottom heavy, or balanced? So this guy is bottom heavy. The degree on the bottom is 3, the degree on the top is 2. So this makes your life easy because if it's bottom heavy, that tells you automatically that you have a horizontal asymptote at 0. So as x approaches infinity, y is approaching 0. As x approaches negative infinity, y is approaching 0. Okay? So every single time you have a bottom heavy function, you can take it to the bank. You're going to have a horizontal asymptote at 0. I don't know what's going on in here, but I know my graph is approaching 0 from the left and right. Okay? Maybe it goes down, maybe it goes up, maybe you're doing some goofy stuff, but I know my behavior. Okay? So bottom heavy, horizontal asymptote at 0. All right. Middle one, is it top heavy, bottom heavy, or balanced? Well, the degree on the top is 3. The degree on the bottom is also 3. So it's just balanced, okay? So what do I do if I have a function that's balanced? So if my function is balanced, I'm going to look at the terms that dominate. So 4x cubed over negative 2x cubed. And more specifically, I'm going to look at the leading coefficients. So my leading coefficient here is 4 and negative 2. So negative 2 is where my horizontal asymptote is going to be here. So let me write that down. So I have a horizontal asymptote at y equals negative 2. And so if you can picture what that looks like on a graph, negative 2. So again, I don't know what's happening inside. I don't know where my y-intercept is or anything, but I know that as x gets really, really big and x gets really, really negative, I'm approaching negative 2. So my end behavior, I'd write it as x goes to infinity, y approaches negative 2. And as x goes to negative infinity, y is also approaching negative 2. So if we have a horizontal asymptote, figuring out the end behavior is not so bad. All right, last one. Top heavy, bottom heavy, or balanced? Okay, so this is top heavy. The degree on the top is 3. The degree on the bottom is 2. So my strategy here, this takes a little bit extra effort. So I look at the terms that dominate. So it'd be 4x cubed and 2x squared. So 4x cubed dominates on the top, and 2x squared dominates on the bottom. So I know my function is going to behave the same as whatever this behaves. So if I simplify, I get 2x. So you need to know, what does the graph y equals 2x look like? All right, well, that's not so bad. It's linear, it has a positive slope, so it's going to look like that. So what does this tell me? This confusing function up here is going to have the same end behavior as this nice, simple linear function here. So as x goes to infinity, y is going where? So as x gets really big, y is going up to infinity. And then as x goes to negative infinity, x gets really negative, my y value is going really negative. So y approaches negative infinity. Okay? So what does that tell me about a horizontal asymptote if it's top heavy? Well, it tells me that if it's top heavy, I'm not going to have a horizontal asymptote. Okay, remember, horizontal asymptote is guiding your graph as x gets really, really big. Well, if it's top heavy, it's not being contained. It's getting really, really big or really, really negative. Okay, so there's no horizontal asymptote if it's a top heavy function. Okay, so hopefully those examples helped a little bit. Good luck with your homework, and let me know if I can do anything to help you.